next term, chapter 6, and the SAC 2 in week 3. So, having a look at this question here, just going to read it out loud. This is estimating turning points, stated interval in which the x-coordinate or the maximum turning point on the graph of y equals x, x plus 2, x minus 3 must lie. What type of graph do we have? A cubic. What type of cubic do we have? Is it positive or negative? It's a positive. So when you know it's a positive, we know. Draw out the basic shape. We're looking for an x interval. We're only interested left to right. We're not interested in up and down. So this first turning point, it says there, a maximum turning point. We're interested in this one. We're ignoring this one because it's not asking the question. We want to find out on the x's where that hill, that first hill, is going to lie. What's the first thing we must do first in order to figure that out? What's the main thing of our graphs, of our cubics, of any graph really? What's the main thing that you usually find out? On the x interval. What is a feature of the x? The intercepts. Okay, so we're looking at intercepts. By reading our equation, what are our 3 intercepts?
-2 and 3.
-2, thank you, Zay.
And 0.
3 and 0. Therefore, just by putting in our intercepts, between which 2 numbers are we focusing on the x? Okay. Which 2? Are we going to focus from -2 to 0 or 0 to 3? Which interval is our maximum going to lie? Between -2 and 0. So that's what we're going to focus on right now. And the way we do that is we're going to go from -2 all the way to 0. We might look at 1 in the middle. We're just looking at what values. What do I put in here? If we're -1.5, and here -0.5, and this should be a -1. Right now, can everyone please, just to make things quick for you, in your CAS, put a define on CAS, define. F of x equals x times x plus 2 times x minus 3. What is the main reason why we define things under CAS? What's the biggest benefit? If we're going to make a whole lot of calculations, it's quick. Okay, you just punch it in. So if I were to find -2 on the next line, type in f -2. You only have to type three things on your CAS, it'll give you an answer. Has anyone got the first one? You don't need to calculate though. Why? They all equal 0. And we also know, as in addition to 10, it's also 0 on the graph because it's the intercept. So over here, we know that's an intercept. Okay. So we know that's 0. Has anyone got -1.5? Has anyone punched that in quickly?
-3.375.
-3.375?
Yeah.
3.375.
Mine is 4.
3.375. 4. Thank you, Nathan. Who's got -0.5? -0.5. 2.625. Good. Bit of teamwork today. Okay, just by looking at our y values, the hill at -2 is 0 at the bottom of the hill. You can see that it's gravitating towards number 4. Okay, that's an estimate. So we can conclude that our turning point is going to be around negative 1, 4. But you might be asked to go a bit further. So we get our magnifying glass and we look at negative 1, and we know that's 4, but if you want to increase, put it under a microscope a bit more, instead of jumping all the way to negative 1.5, let's take it a bit slower and go to negative 1.1. Okay, let's go a bit further and just increment in 0.1. And on the other side, negative 0.9, and I've got also in the notes negative 0.8. So can everyone now, we've magnified our target. We think the turning point is going to be here, but let's try and test some values out. If anything on the values below tell us otherwise. Has anyone got negative 1.2? You just need to punch in F. 4.032. Okay. Negative 1.1, anyone? 0.059. Negative 0.9. Anyone? 3.861. And the last one is 3.648, I think.
Yes.
So we assume that the turning point is at 4. But it's actually, where's it more closer to? Negative 1.1, because that's the highest value on the hill. It starts to decrease out on the left and to the right. This is just an estimate. So we can say the max turning point is around negative 1.1, 4.059. We don't know for sure, but it's a better estimate. You only do this if you're asked to estimate. Later on in semester 2, you'll be finding how to find the turning point exactly. And that's the whole topic of calculus and derivatives. And you're going to have a lot of fun with that. Okay. Any questions?